Imagine a world hidden beneath miles of ice, a place where no sunlight ever reaches, yet something might be alive down there. Jupiter's moon. Europa is more than just another frozen rock in space. Beneath its cracked, icy surface lies a vast, dark ocean, an alien abyss stretching farther than any sea on Earth. And in the crushing depths of that ocean, heated by volcanic vents on the seafloor, there may be something truly extraordinary. Life. Not the kind of life we see in science fiction, no towering extraterrestrials or glowing creatures of the deep, but something much smaller, much more familiar, something that could change everything we think we know about life beyond Earth. For decades, scientists have suspected that Europa's ocean might be habitable, but now, with upcoming missions like NASA's Europa Clipper, we are finally on the verge of uncovering its secrets. Could an alien ecosystem be thriving beneath that thick shell of ice? If so, what would it look like? And more importantly, how did it survive in total darkness under crushing pressures and without any sunlight to power it? The answers might be closer than we think, hidden in the most extreme environments of our own planet. Deep beneath Earth's oceans where the sun's rays never penetrate, life has found a way. At the bottom of the Pacific, clustered around hydrothermal vents, bizarre creatures thrive in complete darkness. These vents, spewing mineral-rich water heated by the planet's core, create entire ecosystems independent of sunlight. Giant tube worms, ghostly white crabs, and bioluminescent fish survive here, sustained not by photosynthesis, but by chemosynthesis, a process where bacteria extract energy from chemicals instead of light. This discovery changed our understanding of life's potential, proving that entire ecosystems could survive in conditions once thought impossible. And if life can do that here on Earth, why not on Europa? Every great journey starts with a few brave explorers. Right now, Cosmic Whispers is just beginning, and your support means everything. If you enjoy unraveling the mysteries of the universe, hit subscribe. It's free and it helps us grow this community together. Europa's surface tells a story of violent upheaval. Unlike other frozen moons, its ice is not ancient and undisturbed. It is fractured, reshaped, and in some places, stained with strange reddish-brown streaks. Scientists believe these streaks could be evidence of salt and organic compounds from the ocean below, seeping up through cracks in the ice. Even more intriguing, in 2012, the Hubble Space Telescope detected massive plumes of water vapor erupting from Europa's surface, shooting over 100 miles into space. If confirmed, these plumes would mean we don't even have to drill through miles of ice to study Europa's ocean. Samples could be collected directly from space, offering a glimpse into the alien waters hidden below. But Europa is not the only moon of Jupiter, hiding an ocean beneath its surface. Ganymede, the largest moon in the solar system, also holds a deep subterranean sea. Unlike Europa, Ganymede has a powerful magnetic field, something no other moon possesses. This magnetic field was first detected by the Galileo spacecraft in Sightings 1996, and its unique behavior suggested something shocking: a vast saltwater ocean conducting electricity beneath the ice. Later observations by the Hubble Space Telescope revealed glowing auroras shimmering around Ganymede, their shifting patterns confirming what scientists had suspected all along. An ocean, locked beneath miles of ice, potentially holding more water than all of Earth's oceans combined. Then there's Callisto, an ancient and heavily cratered moon, long considered geologically dead. But recent studies suggest that even here, beneath the battered and frozen surface, there could be a hidden ocean. Unlike Europa and Ganymede, Callisto's ocean would be buried much deeper, possibly making it less suitable for life. But the mere fact that liquid water exists in so many places across the Jovian system is astounding. Water is the key ingredient for life as we know it, and where there is water, there is always a chance, however small, that something may be swimming in the darkness. And yet, despite all these tantalizing clues, Europa remains the most promising place to search for extraterrestrial life. Its ocean is in direct contact with a rocky seafloor, just like Earth's, meaning it could have the necessary chemical interactions to support life. If hydrothermal vents exist on Europa's seabed, they could provide the same energy-rich environment that sustains deep-sea creatures here on Earth. This is why scientists are so eager to send missions to explore it. The Europa Clipper, set to launch in the coming years, will fly past the Moon dozens of times, scanning its surface, analyzing its chemistry, and searching for evidence of those towering water plumes. If the plumes contain organic molecules or even microbial life, it would be the most profound discovery in human history, the first confirmation that life exists beyond Earth. But what if we could go even further? What if we could send a probe to melt through Europa's ice, dive into its ocean, and search for life directly? A concept known as a cryobot, a robotic lander designed to generate heat and slowly tunnel through the ice, could one day make this mission a reality. If it reaches the ocean, it could deploy small autonomous submarines exploring the depths and capturing images of whatever lurks beneath. The idea sounds like science fiction, but it is a serious proposal being developed. By NASA and other space agencies, Europa's secrets remain locked beneath its frozen shell, but not for long. The search for life in our solar system is about to take a giant leap forward, and when we finally pierce the veil of ice, we may discover that we are not alone. Beneath Europa's frozen surface, the darkness stretches endlessly. No sunlight has ever reached these alien waters, yet something extraordinary might be happening here. If life exists on Europa, it would be unlike anything we've ever encountered, adapted to an environment of extreme pressure, perpetual night, and a complete absence of surface weather. To imagine what might survive in this abyss, we need to look at the closest analogues we have on Earth, creatures that thrive in the crushing darkness of our own deep oceans. On Earth, the deep sea is a realm of extremes. The pressures in the Mariana Trench, the deepest part of our oceans, are over 8 tons per square inch, enough to crush a human instantly. Yet, life persists. Strange, gelatinous creatures float through the water, completely blind, sensing their environment through vibrations and faint chemical signals. Deep-sea fish have evolved enormous ghostly eyes to detect the tiniest glimmers of bioluminescence, flashes of eerie blue-green light emitted by other organisms. Some, like the anglerfish, use glowing lures to attract prey, while others produce sudden bursts of light to startle predators. If Europa's ocean is anything like this, it could be filled with similar adaptations. But there's one major difference. On Earth, these creatures still rely indirectly on the sun. Even in the deepest trenches, nutrients from the surface eventually sink downward, providing food for scavengers and filter feeders. Europa has no such connection. Its ocean has been sealed away for potentially billions of years. The only energy source it could have comes from the Moon's own internal processes: geothermal heating from hydrothermal vents, chemical reactions between rock and water, or perhaps even weak traces of radiation from Jupiter's intense magnetic field. This makes Europa's ocean a true test for the limits of life. If anything is alive down there, it must have found a way to survive purely through chemistry. Much like the microbes that thrive around hydrothermal vents in Earth's oceans. These vents, cracks in the ocean floor where superheated, mineral-rich water gushes out, are home to entire ecosystems that don't rely on sunlight at all. Instead, they are powered by chemosynthesis, where bacteria use sulfur and methane as an energy source. These bacteria become the foundation of a food chain that supports giant tube worms, blind shrimp, and even massive crabs. If similar vents exist on Europa, they could create similar ecosystems, alien yet eerily familiar. But even if no large creatures roam the depths, Europa's ocean could still hold something just as significant: microbial life. The discovery of even a single microscopic organism in Europa's waters would be groundbreaking. It would mean that life is not unique to Earth, that biology is not a cosmic accident, but a natural consequence of the right conditions. And if life can emerge twice in the same solar system, then the universe must be teeming with it. Yet despite all this potential, we are still only scratching the surface, literally. The ice covering Europa is not a thin crust. In some places, it could be over 12 miles thick. Drilling through it would be one of the most difficult engineering. challenges in human history. And even if we succeed, there is no guarantee that we will find anything. Europa's ocean could be sterile, its waters too toxic or too devoid of energy to support life. There's also the question of contamination. If we send a probe to Europa and accidentally introduce Earth bacteria into its ocean, we could end up corrupting any native ecosystem before we even detect it. That's why missions like the Europa Clipper will focus on indirect methods first, scanning the moon from orbit, analyzing surface chemistry, and searching for organic compounds in the water plumes that erupt into space. If those plumes contain evidence of life, then and only then will we consider sending a lander. But Europa is not alone in hiding a vast alien sea. Other moons in the outer solar system may also hold deep subsurface oceans. Ganymede, the largest moon in the solar system, has an ocean buried beneath over 90 miles of ice, far deeper than Europa's. While this extreme depth makes it less accessible, it also means there is a greater chance that life, if it exists, has been undisturbed for billions of years. Then there is Enceladus, a small but incredibly active moon of Saturn. Unlike Europa, Enceladus is constantly spewing massive geysers of water into space. Meaning we don't need to drill at all. Samples can be collected by simply flying through its plumes. The Cassini spacecraft did exactly this in 2015, analyzing the material ejected from Enceladus's geysers. What it found shocked scientists: complex organic molecules, including carbon compounds essential for life. This was the first direct evidence that an ocean world beyond Earth contains the building blocks of life. Enceladus may be smaller than Europa, but in some ways it is an even more promising candidate for habitability, and yet Europa remains the prime target. Its ocean is older, larger, and in direct contact with a rocky seafloor, meaning it has all the necessary ingredients for life as we understand it. Missions to Enceladus and Ganymede will undoubtedly continue, but Europa is the one that could give us the most profound discovery of all. The question is no longer if we will explore it, but when. When we finally send a probe to pierce Europa's ice, what will we find? A barren, lifeless abyss, or something swimming just beyond the reach of our cameras, something that has been waiting in the dark for billions of years? We may be closer to answering that question than ever before. As we look deeper into Europa's hidden ocean, we must consider what conditions truly define its environment. Unlike Earth's oceans, which are shaped by tides, currents, and weather, Europa's sea is locked away beneath a thick, unbroken shell of ice. No storms churn its waters, no sunlight filters down to create warmth. Instead, the entire ocean is governed by the immense gravitational forces of Jupiter itself. The gas giant's powerful pull distorts Europa's interior, generating friction and heat, enough to keep a vast ocean from freezing solid. This process, tidal heating, may be the key to sustaining an ecosystem beneath the ice. But what exactly does that ocean look like? Most of Earth's oceans have a well-defined structure: sunlit surface waters, a middle layer where temperatures rapidly drop, and the abyssal depths where only the most extreme life forms survive. Europa's ocean, however, is a world without light, without wind-driven currents, and possibly without a stable seabed. Instead of a rocky floor like Earth's oceans, Europa's deepest waters could be in direct contact with a seafloor that constantly shifts and fractures under the strain of Jupiter's gravity. This means hydrothermal activity is likely, superheated water erupting from the moon's interior, carrying minerals and energy that could sustain life. Similar environments exist on Earth. The Lost City hydrothermal field, located in the Atlantic Ocean, is a towering labyrinth of mineral formations where life thrives in the absence of sunlight. Unlike the black smokers commonly found on Earth's ocean floor, which emit superheated acidic water, the Lost City vents produce alkaline fluids rich in hydrogen and methane, both crucial for microbial life. This unique ecosystem is thought to resemble the kind of environment where life may have first emerged on Earth. If Europa has similar hydrothermal systems, it could mean that its ocean is not just habitable, but potentially home to thriving alien organisms. However, Europa's ocean is not an isolated system. It interacts with the ice above it in ways we are only beginning to understand. Cracks and fissures on Europa's surface suggest that water from below sometimes wells up, freezing into new layers of ice. This means that material from the ocean is being transported upward and possibly even ejected into space through geysers. These geysers, first observed by the Hubble Space Telescope in 2012, offer a tantalizing glimpse into Europa's hidden depths. If we can sample them directly, we might detect organic molecules or even microbial life without ever drilling through the ice. These discoveries have sparked a new wave of exploration. The Europa Clipper mission, set to launch in the coming years, will be humanity's most ambitious attempt to study this alien world. Unlike past missions that merely flew by Europa, this spacecraft will enter orbit around Jupiter and perform dozens of close flybys of the Moon, scanning its ice, measuring its magnetic field, and analyzing its thin atmosphere for signs of life. If the Clipper confirms the presence of organic compounds or other biosignatures, it will set the stage for a future lander, one capable of drilling beneath the surface and directly exploring Europa's hidden ocean. But Europa is not the only place where these mysteries exist. Other moons of the outer solar system may also conceal vast liquid oceans beneath their icy crusts. Ganymede, the largest moon in the solar system, is believed to have more water than all of Earth's oceans combined, locked beneath a layer of ice nearly 100 miles thick. While this extreme depth makes exploration difficult, it also raises the possibility that an untouched ancient biosphere has existed there for billions of years. Then there's Callisto, another of Jupiter's major moons. Unlike Europa, Callisto's surface is heavily cratered, suggesting that its ice has remained largely unchanged for eons. But beneath that icy shell, there could still be a vast ocean, isolated from the surface, yet potentially home to its own unique forms of life. Unlike Europa and Ganymede, Callisto is outside Jupiter's most intense radiation belts, making it an ideal candidate for future human exploration. And we cannot ignore Saturn's enigmatic moon, Enceladus. This tiny world, only 300 miles across, has astonished scientists with its towering plumes of water vapor, which erupt from cracks near its south pole and extend hundreds of miles into space. These geysers have allowed us to directly sample the contents of an alien ocean without ever landing. When NASA's Cassini spacecraft flew through one of these plumes, it detected not only water and organic molecules, but also tiny grains of silica, evidence that hydrothermal activity is occurring on Enceladus's seafloor. This discovery means that Enceladus, despite its small size, may have one of the most habitable environments in the solar system. But if these moons all have liquid water, energy sources, and organic compounds, why haven't we found life yet? The answer lies in the challenges of exploration. Unlike Mars, where rovers can simply drive across the surface, ocean worlds require entirely new technologies to study their hidden depths. Future missions will need to deploy autonomous submarines, robotic explorers capable of navigating alien oceans, mapping seafloors, and even searching for living organisms. One such concept, called the Europa Lander, envisions a spacecraft capable of drilling through Europa's ice and releasing a small submarine-like probe into the ocean below. This probe, equipped with cameras, chemical sensors, and even robotic arms, could explore the abyss for signs of microbial life, or perhaps something more complex. If we ever detect a moving, self-sustaining organism in Europa's waters, it would be the most profound discovery in human history. And that brings us to the most haunting question of all. If life exists beneath Europa's ice, how advanced could it be? Most astrobiologists expect that at best we will find microbes, simple, single-celled organisms thriving in extreme conditions. But what if, over billions of years, life has had the opportunity to evolve? Could Europa's ocean support something larger, something that moves with intent, something that might even be aware of its surroundings? We cannot know for sure, yet. But one thing is certain. When we finally send our first robotic explorers into these hidden oceans, we must be prepared for the unexpected. What we find beneath the ice could redefine our understanding of life, the universe, and our own place within it. And if one day a camera lens peers through the darkness and captures movement, something swimming just beyond the reach of our lights, then everything we thought we knew about the cosmos will change forever.